Okay, so welcome next session. We will see is we will first see the recap of last session which we were doing, and in the last session we handled multiple regression. Okay, so multiple variable regression. Let me tell you everything. Okay, right from beginning. We started with the data analysis. Directly we cannot jump with the machine learning. So what is analysis? Sir, if we are having any kind of data, we are going to analyze that with the help of some tools and techniques that are called as machine learning tools and techniques. Okay, that is mean by data analysis. What data can we analyze? So numbers, alphabets, images, videos, audios, anything we can analyze. From which only single part currently we are analyzing. Which is that, sir? Only numerical part that you can observe. Why I'm revising this much? Because you have observed that I have converted yesterday the text format of data into numerical format of data, and then I'm doing the analysis. So why I need to convert that? Because currently you don't have any knowledge regarding text analytics. It is different subject. We are now only learning how to handle numerical data. Okay, that we are seeing. Then slowly we saw that to analyze we have different kind of analysis. First analysis is descriptive analysis. We saw that how to do the descriptive analysis, basic descriptive analysis. Then we saw that after making some graph we have to write some insights also. And then slowly we thought of predicting next value, which is called as predictive analysis. After descriptive we jump towards the predictive. Now for predictive analysis we have some algorithm. Okay, machine learning algorithm. And then we stated machine learning. What is machine learning? If we have a data set, our machine tries to learn what is the pattern hidden inside that data. That is called as machine learning. If predictions we have to make, we have to use some regression type of algorithms. Many kind of regressions are available, from which first we have seen linear regression. What do you mean by linear regression? Sir, if we want to predict next near future values. Near future means we can predict 100 years of data also, but we predict few months of data. Why? That will improve our accuracy. No one knows what will happen after even 1 year. Okay, so that is why linear regression or any regression means predicting the values in the near upcoming future. If data behaves in the linear fashion, if my data behaves in the linear fashion, it is called as linear regression. Simple terms, it is called as linear regression. Then how we describe that? Yesterday I showed you a code where year of experience was there, and and the salary was given. What is the salary? Based on that you understood, sir, if 1 year of experience is there, something is the salary. 1.2 years of experience, something is the salary. 1.3, 1.5, 1.6, respectively, all the salaries are mentioned. In this way, data is there. If you carefully observe, here my data is behaving at least near to my straight line. If I draw a straight line, okay, anyhow, it can be horizontal, vertical, or at any angle, 30 degree, 40 degree, 45 degree, 60 degree, at any angle. But imagine a straight line. If my data points lie in that straight line, it is called as linear behavior. Okay, so we entered into linear behavior and then we saw, sir, for our given data set, whatever data set currently we are trying to analyze, okay, for that given this data set, this is my original data set, linear regression is not working, sir. Why, sir? Because only one single variable we are taking. Okay, what is our target variable here? We have to predict the revenue. So revenue is our target variable. There are missing values, sir. In the pre-processing, we have filled missing values with some data. What data we can fill? Can we fill it with the mean value? No, sir. Why not with the mean value? Sir, if this data we carefully observe, someone is adding only address. It is clearly common sense that revenue is zero only. Correct. So we should not replace with mean, mode, median, or something. Replace with zero value. Why? Only someone is adding only address, but not purchasing anything. Only adding the address. Okay. So revenue is zero. Now, what is happening is I am taking serial number, trying to predict revenue. Then I will take touch type. Okay. Then I will predict revenue. Then I will take this time series analysis. We are not going to see right now. Okay. If you have interest, I will teach it after. few algorithms. Okay, then based on event name, we try to predict the revenue. In this way, I told you yesterday, based on different columns here, you can try to predict what will be my revenue. And you will observe one thing, sir, any column will not help us to give the good accuracy. We are getting huge errors, sir, huge errors. Okay, our main predictions are for only address addition. Those people who are only adding addresses, its actual value is zero. Revenue should be zero actual revenue. Prediction is telling me value are 200 something, completely blunder. So we will not accept this model, sir. Then what we will do? Then we have decided, sir, instead of taking one factor, what we will do is, sir, we will take combination of factor. Means what? We will uh, decide that event revenue is not dependent on only one factor. Who is affecting event revenue? Serial number might affect, touch type might affect, timing also might affect, event name also might affect, cities might also affect, everything might affect. Correct or not? So slowly what we have decided is event revenue is not dependent on single factor. It may depend on multiple factors or multiple feature, whatever you call it in simple terms. Okay. So what is happening here? If multiple variables we want to take, sir, it comes under linear regression only, but it is now multiple linear regression or multivariable linear regression. Why, sir? Because, sir, x and y variable are there. See, in this algorithm, we have defined, first of all, what we have defined, we have imported all my libraries. Then what we have done is we have written the path of file and we have imported the data. Okay. After importing data, this is my normal data overview descriptive analysis. This you can skip for now. Okay. After doing this, sir, we have converted text format of data into numerical data of this column, event name column. Okay. And then what we have done is we have divided our data in two types. Okay. X and Y. X variable, Y variable. So what is happening if X and Y is there? Y variable indicates target variable only in which revenue is stored. In X variable, we can store as much as variables we want. Previously, what we were doing is we were storing only one kind of variable. In simple example, I would like to explain difference between simple linear regression and multiple linear regression. Imagine, imagine that all my students in the class, I want to decide who is very fast in the assignment. Okay, who is very fast in the assignment. Let's say everyone has received the assignment details at 8 p.m. after my class. Everyone has received. Now at 9 p.m., Rudra has messaged me first on the group. Sir, my assignment is completed. Then Abhinaya has mentioned. Then Ramya. Then Vinith, Rishabh, Karishma, and slowly everyone. Now, how I will decide who is the winner of that competition? My competition was whoever will be, giving the assignment on time or as quick as possible with all the given instructions on the instruction sheet, he or she will be the winner. Rudra has completed first, but there are mistakes. So can I declare Rudra as winner? No. So what you have observed here, sir, if we decide based on timing, obviously Rudra is winner, sir. Why? Rudra has given first. Our target variable is who is winner. Okay, what are your ranks? Rudra has submitted first, Abhinaya second, Gurucharan third, Siresha fourth. So whose ranking is what? That we are trying to predict, that we are trying to decide. But based on only one factor, that is timing. Based on timing, if I want to decide, yeah, Rudra is winner. But let's say based on correctness of the assignment, then I saw no, Rudra, your assignment is wrong. Shresa assignment is correct, or Gurucharan assignment is correct. Then I will decide. Now Gurucharan is also winner, Shresha is also winner. Why? Both assignments are correct, but only one factor I am analyzing whose assignment is correct. So there are multiple winners. Multiple winners. Everyone is at first position. Many of them are at first position. Then I got to know we cannot take a single factor into consideration. What we have to take? Sir, we have to consider correctness as well as at the same time we have to consider time, as well as we have to also mention at the same time other factors. Based on maximum possible factors, we have to decide which is the best possible student in our class. Correct. Not, we cannot consider 3 to 5 factor. It is also wrong to say only 3 to 5 factor, Shiresha. We need to consider maximum possible factor. Sometimes what will happen? You have only 2 factor. Okay, I will show you why I'm telling this. See, in my data set, if you carefully observe, in this timing analysis, I have not taught you currently. So time is irrelevant for you. So how many columns are there for analysis? So serial number you have taught us, attribute touch type is there, and event name is there. If you try to analyze with the help of event value, na, you will not understand, because this event value, this is written in a dictionary format. Currently you don't know how to analyze that. Okay, then you try to analyze with USD INR, USD INR, meaningless column is there. Why we will analyze with this? No. And this revenue is in the same format. Okay, we will not also take into this consideration. In this way, if you carefully observe, okay, you will see that maximum uh, columns are irrelevant. Maximum column are irrelevant for us. Only few columns are relevant. That might be, in some cases it might be 2 columns are relevant. Some cases 3 4 columns are there. 5 6 10 columns are there. Whatever column might be there. Our intention is to only find how many columns are there which can be relevant. Okay, in this way what I have done is I have taken 3 columns. This is the step where from my entire data set, where is my entire data set store? File variable. Then what I have done, I want all the rows. How I have mentioned that all the rows? With the help of semicolon, sorry, colon. By writing colon, I am mentioning all the rows I want, but column which I want, column number 0, 5 and 7. Column number 0 means serial number, 0, 5 means this, okay, and 7 means this. Always I want 7. Why? For 7 only we are doing analysis. 7 is my target variable. Okay, so in this way I have taken my small data set from my large data set, which is relevant for me. Okay, and stored it in the data set. Then I found missing values, filled the missing values. Data set is ready in front of me. Okay, I've converted my text data into numerical data also, upside only. Okay, and then what we have seen is, sir, after converting everything, now what we have to do is we have to store our event revenue into y variable. Event revenue in y variable. Rest two columns, rest two columns into x variable. That only I have done. From data set, zeroth column is the serial number that I want to store in x. Also, first column I want to store means event revenue. And then I have performed same thing. Nothing I have changed. Nothing I have changed. What is the change then? What change had happened? Only the change what is happened here is in the x. So I need to run this. Just 1 minute. I need to run this again. Hmm. So what change has happened? So changes happen only in X. Previously, only one factor was there in X. Now two factors are there. Serial number also we can see, and there is some event value for that, or event name. Sorry, event name is there. Okay, serial number, event name, serial number, event name. Two values are there in X. Okay, nothing else. So all things will be same. Regression formula will be also same. Everything will be same. And then we saw prediction that this is the number. And yesterday I told you this number. If you search, what is the meaning of this number? E raised to minus 15. How it is pi value is there in the mathematics. In a similar way, E is the number, Euler's number. It is the number, some mathematical number which has some value like pi. Okay, and that number is having power of minus 15. Means what? Whatever prediction we are getting, it is in negative format, but very, very, very much small, very much close to zero. Previously, if you see with simple linear regression, we will get here predictions as 266, 250 something. That is totally inaccurate data. But if here you see what is my data, okay, what is my predictions, it is close to zero. Then what you will say, sir, slowly, slowly we are getting some, at least a little bit of accuracy. Little bit. It is not completely true, little bit. How we have verified that, sir? So what we will do is we will verify it by asking our customized prediction. Okay, let's say my serial number is 15,000. Okay, 15,000 is my serial number. Now 15,000 is my serial number and event value, sorry, event name. Event name is 0. What do you mean by event name as 0? If you carefully observe, event name 0 means address addition. Address addition. This is my first event. So this is 0. Event name as 1 means first wallet recharge. Event name as 2 means first subscription, and 3 means first top up. So in the same way, what I'm mentioning is 15,000 as my serial number and 0 as my event name. What do you mean by 0? Customer number 15,000 is adding only address. If I run this, I'm getting some negative value, but it is e raised to minus 15. Means what? Sir, this number is very much small, very much. 0.00000, this much small. It is close to 0. Correct, sir. Why? Because if someone is only adding the address, there is no any revenue, but still there is some inaccurate data. Why? Because still this number is not exactly 0. Okay, so this data is having some accuracy but not very good accuracy. This is what our yesterday's conclusion is there. Got it? Now if I change here, instead of 0, if I change here like let's say 150 and 0, then also number close to 0 only there. Okay, but if I change to 1, now 1 means what? First wallet recharge. Someone is adding money to their wallet in the application, e-commerce application. So what we have to do, we will get some kind of revenue. I don't know how much revenue is there, but we should get some revenue. And then we saw that if even I change anything, I'm getting only 1.0, 1.0, 1.0. Means what? This is also not good data. If 0 value is there, I'm getting 0. That is good. But if 1 value is there, 1 value means what? Someone is adding some rupees in their wallet. How much rupees? That rupees I am getting here. That rupees I'm getting in the prediction. That rupees is 1 rupees. So everyone is adding 1 rupees. This prediction is wrong. I will try to check for event name 2. Then you will see 2.0. Means what is happening? Sir, if I'm taking serial number and if I'm taking serial number and event name togetherly, then also I'm not getting very good accuracy. This is the conclusion of yesterday's data. Then what you can do, sir, change the variables now. Instead of taking serial number and event name, what we can do is we can take this column, attribute touch type and event name. Okay, then also if we are not getting good accuracy, then change the data again, event name and let's say cities, or you take three variable, attribute touch type, event name and cities, or take four variable, five variable, six variable, as per your decision, but it should give us the good accuracy, and you have to check that accuracy with the logical way. So is it clear till now? Let me know, everyone. If you are having doubt, you need to solve it, or you need to give some time by yourself also, otherwise you will not get it. You got it? Okay, now this was my yesterday's conclusion. Those students who are having doubt now, they can just call me after the classes after 10:30. Okay, I will be free after 10:30. They can message me or call me after 10:30. I can give them separate attention if they want. Okay, now imagine that. Now what is, sir, what is the another way, sir? We tried linear regression, then also we didn't got accuracy. We tried multiple linear regression, then also we are not getting accuracy, sir. And then what we will do? So here we are going to introduce about new algorithm, which is polynomial regression. Again I will tell you, everything is same. Okay, now data set, I have taken a simple data set for you. Okay, this is the dummy data set, sample data, to only explain how everything work. Okay, first I will explain like what is polynomial regression, then we will apply it on our data set. Okay, first what we have to do, import the same libraries, same as it is, same libraries are there, sir. Then what we are going to do, we are going to import our data set, and we have stored it in the variable called as data set. Where is my value stored? Currently I can write this. You have to write here entire path, C drive, E drive, F drive. Okay, wherever you have stored, or desktop, downloads, or any folder. Okay, you have to write it. Don't write as per my files. Huh? You have to write your own path. whenever I will give this data set to you. Okay, then what we have to do is, after importing the data, I've divided my data set. First, would you like to see the data? Let us see the data set first. Okay, so I will add a, this is my data set. Simple thing is there, my only small data set is there, position of my interns and their levels. I've just mentioned the levels and their position, and their salaries are there. Let's say I hired Rudra as business analyst after this course, and I'm giving some salary. I hired Abhinaya as a, let's say, junior consultant, giving some salary. Similarly, all the students and salaries are written over here. Okay, now based out of this, I want to predict what will be the salary of any other position, how it will be there, how salaries are varying. Okay, what you can think, sir, can we do the linear regression? Let us try. Okay, let us try. If we take only one variable based out of level, if we try to predict salary, it will be simple linear regression. If we take multiple variables into consideration, it is called as multivariable or multiple linear regression. Still it is linear regression. Why? Because we are going to import linear regression. Okay, with the help of fit function, we are going to train the data. As easy as that. Now you will ask me, sir, why you have not divided data into training and test data? Where is that step? Train and test split. Can anyone tell me? You should tell that, sir. If you see carefully how much is our data, it is only 10 number of rows are there in our data set. Is it is in front of you? Okay, you can check that only 10 rows are there, and due to which my data set is too much small. Now in this, what I will divide, if let's say I have only 3 4 examples to teach you. Okay, in that 3 4 example, how much example I should teach and how much example I should ask in exam, I don't have much choices. That's why what I thought is, okay, instead of giving some data into training and test data, directly I have given entire data into training only. Random values I will check for analysis, for predictions. But right now it is very much essential for our model to give maximum possible data. Maximum, it is a rule that, imagine if I am taking only 100 rows in my data set to analyze, I will get some accuracy. Okay, it will be not so good. If I try to improve it by any other way, I will not get it. Why? Because only based out of 100 rows, how machine can analyze hidden pattern in that. Machine will say, give me more data, let us spend some more time. Instead of 100 rows, give me 200, 1000, 1 lakh, 1 crore rows. And then I will understand, okay, what is actually happening year on year, month on month, and everything. Okay, so this is how actually everything is. Means, you have to think. So if my data set is given, blindly don't think of, sir, divide into train and test data. No, data set is small, so don't divide. Directly use the fit function to train the data. Okay, so here the data is trained. Now I have visualized my data in front of you. So you can see that, if see level number is 1, what is the salary? Level number 2, what is the salary? In this way, level number 3, 4, 5, 6, 7, 8, 9, 10. And you can see that linear regression means, now we understood, sir. Straight line is there, but actual points are red spot. The red spots are actual points, and blue line is indicating my regression line. Blue line is called as regression line. Means what, sir? So blue line, if we extend it further, it will give me the predictions, and red spots are actual values. We can clearly see, sir, predictions will go wrong. Why? We have to draw some curve according to our behavior, existing behavior, not according to our convenience. Okay, so here we got to know why our models are being failed. So why it is failed? Because our data is not in the linear behavior. My data is behaving in the random fashion. Whatever fashion is there, but random it is there, not linear. The distance between actual point and the perpendicular, if we draw perpendicular in this line, on this line, okay, the distance between actual point and the blue line is called as error. Okay, just imagine point number 1 is there, actual salary is something this, actual salary is something this. Okay, but my prediction is telling here. My prediction is telling here. So actual value is much higher, prediction is telling much lower. Point number two, actual value is here, red line, a red spot. My prediction is telling here, low error is there. And third spot, actual value and prediction value are coinciding each other. So my prediction is good. Okay. Then fourth point, fifth point, sixth point, you can see that errors are there. These are called as errors in the regression. These are called as errors in my regression. There is much more to learn in the linear regression, but due to the time constraint, I cannot teach you right now entire detailed discussion on regression. But you have understood right now the basics of regression. Okay, so this is how, sir, linear is there. Now, sir, by common sense, we can decide that, sir, instead of straight line we can draw a curve, sir, and that is where we comes under the polynomial regression. This is the function used for polynomial regression. How multiple features were there, instead of multiple feature we will change the degree of our curve. We will not use now linear regression, it is now polynomial regression. This is the function that we are going to use. Again, that function we are going to store in some small variable. Linear regression, we can store it in the small variable. Okay, that small variable name can be anything. I can write it at only lr, or only reg, lin, vinith, rudra, anything name I can write, but small name I should write. Okay, similarly here also I will write small name. Only the thing is, in the bracket I will also mention what is the degree of curve. Which curve we will see slowly. Okay, we will write degree of curve. Okay, degree means what, sir? Sir, degree, if we have not mentioned, it will take straight line. If we have mentioned degree is equals to 2, say degree has not mentioned means what? Degree is equals to 1. What do you mean by degree, sir? Y is equals to mx plus c is the equation of straight line. If we change degree of x, means what we are changing? So we are making x square. So degree is 2. X raised to 3 means x cube means degree is 3. X raised to 4, degree is 4. Okay. So in this way we are changing the degrees. Alright. Now what we'll do is, here degree is there. Okay. Polynomial feature, in this way we will define. We have to transform first. Okay. We have used the fit transform function to transform, and after that we have used the fit function to train my polynomial regression model. So what is this step? This is only addition. This step, fit transform, this is my additional step. The rest step is same. So why we are going to transform? What do you mean by transform? Let us understand. Sir, just imagine that all my salaries are in lakhs, few salaries are in 10,000s, or okay, in 5 digits, some salaries are in 4 digits. Okay, what I am going to do is, I'm going to define a scale. Okay, I cannot means change my calculations always. Now I will define a scale. Let's say from 0 to 10, I will transform my all values in between 0 to 10. Okay, what it will happen is, it will make my calculations easy. Relatively I will calculate all the things relatively. Okay, so each and every salaries will be converted in the range of 0 to 10 accordingly, in the proportion. Or it can be also transformed into -1 to 1, based on how you transform it. There are many much transformation functions, scaling functions. Okay, it is called a scaling or transformation function. Many more functions means standard transformation or standard scaling, decimal scaling, z scalar scaling. Many are there. Currently we have not used that much. Only a simple fit transfer function we have used, and we have transformed the data. Then what we are going to use is, we are now going to see visualization of my polynomial regression, and then you can see, okay, points are there, and my this is my curve. If I change this to degree is equals to 2, okay, if I change degree is equals to 2, so let us see what will happen. Le- Linear regression is same, polynomial regression will change. See, you have seen the change. This is the degree is equals to 2 parabola, y is equals to x square plus some c parabola. Some errors are still there. So what I will do, sir, degree is equals to 3 should be there. Okay, sir. Now it is good. But still there are errors, sir. Can we make it degree is equals to 4 and then we will test? Yes. And then we got to know with the experiment degree is equals to 4 is the perfect solution for this. Do we have to take this perfect solution or not? That depends upon us. After this classes, I am going to teach you overfitting, underfitting. Many concepts are there. Many concepts are there. But based out of some concepts, we will see that which kind of degree we have to take. Degree is equals to 2, 3, 4. How we will take that? Okay. Is it clear till now then? Only the code is changing. Instead of linear regression, only this much code is there, which is for polynomial regression. And then we are going to visualize the output of polynomial regression. Nothing else. Is it, means have you understood it? Is it easy to understand? Only coding part is changing. Nothing else. Prince is asking, sir, do we require a good amount of data to be get tested? Yes, Prince, obviously. Okay, Gurujan. See, why we require more and more data? Simple thing is there. If I ask you, Prince, based out of one test, I will judge you. Like, Prince, you have scored 20 out of 20 marks in my test. Is the Prince genius? No. How I will decide then? Let the more test happen. Second test in the college will happen. Then Prince has scored 0 mark. So can I judge again? No, no, no. I judged wrong. Prince is actually a duffer. I cannot tell even that. Then what I will do? Take more and more data, and then you will see why people in post graduation ask your 10th standard mark, 12th standard mark, graduation mark. Why they will ask? Can't they ask directly your graduation mark? Why they will ask? Because they want to see how is your progress, how much you have scored in 10th, 12th, and then in graduation, how year on year your growth is there. Based out of that, they will see that okay, if you are not making growth, so something else you have might have done. Similarly, here also we have to see maximum possible data. Okay, so this is what I was telling is till here it is clear to everyone. Like this is my data. With the help of this code, I have applied the linear regression function. Already we have seen. Okay, no one can remember this. You have to practice, 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 and you can remember. This is only a coding language. Okay, so you have to do the same thing. From last 2 3 days, we are doing the same thing. So this I think it should be clear. In this line, we are importing linear regression function. I'm storing linear regression in some small variable. Then with the help of fit function, I'm training my model. So I'm training linear regression model. Output of that linear regression is here. How it is, sir? Red spots indicate my uh, actual values. Where are actual values, sir? Here, sir. I have already taught you in last lectures. You can watch the previous recorded sessions where PLT scatter, how we have made, and what kind of graph we are getting, why we are getting. Descriptive analytics, we have seen that. Okay, and then predictions. With respect to X, we are going to get the predictions in the blue line or in the blue color, and then we got a line. Okay, when we try to ask predictions of X, machine is giving us straight line. Why? Because we are giving the linear regression model. So linear regression model is in front of you. Similarly, I am telling that instead of linear regression, now I am going to use the polynomial regression. How to use, sir? Function is changing. Polynomial feature, this is the name of function. Okay, in this function what is necessary? Necessary is to mention what kind of degree you have to use. Okay, and then you have to transform your data. Okay, even if you don't transform, you can do it for some data, otherwise it will give some error. Why error? The scale needs to be decided. Now you can see that scale is defined from 0 to 1. The scale is defined. All the salaries are compressed in the range of 0 to 1. Correct? That is why we need the transformation. And then with the help of fit function, we have trained the model. So this is the code for polynomial regression. That's it. With the help of polynomial regression, what is the difference that we are getting? That we have visualized here. So instead of here, you can see the code has changed here. Prediction model. I have written here prediction model, and this is how it is getting the change in the polynomial regression. Okay, so I will share this data with you. Okay, you can read this, means not read this actually, you can run this in your local computer. So I'm sharing right away with you. Got it? So where is the group? So Xenix, I have shared. Just let me know have you received the data set, means the code. And for this code, I'm also sharing you the data set which you have to work. So just go and implement this code and then try to understand. If you don't get anything, you can just tell me. Okay. Don't wait even for the next class. You can just message, scan the screenshot, or you can just send me the, means you can call me even. Okay. All right. So thank you, Ramya and Rudra, to confirm that. You got it? Okay. Done. So this is how actually we are going to see polynomial regression. Let us apply that polynomial regression on our own data set. Let us apply that. Okay. How we are going to apply that? Sir, this is our data set. Okay. Means this is what libraries we have imported. This is my data set stored in file. Okay. This is everything is same. Data overview is same, descriptive analysis is same, data visualization basic, everything is same, sir. Everything is happening same. Okay, same in here. Now in the data set I have stored only two variable. Here you can see column number 0, column number 7. From where? From file. What is my file? Entire big data set. From that big data set only column number 0, column number 7 I have taken, and all the rows I have taken. How it is mentioned? With the help of colon. All the rows, but only column number 0, column number 7 I have taken. Stored it in the data set. How data sets look? Here, in this way. Okay, sir. With the help of serial number and event revenue, I have done all the pre-processing also. I will not tell that. Replacing missing values and everything. Okay, done. Now, linear regression. How we are going to apply? Sir, divide my variables in X and Y. Store serial number in X, event revenue in Y. So we have done this. Okay, X is in front of you, Y is in front of you. Now what we are going to do? We are having 13,000 rows in our data set. Here 10 rows are written, but I have used here head function and I have used here 10. That's why it is showing 10. If I mention nothing, it will show me 5. If I mention here 100, it will show me 100. So what is my actual number then? So that actual number you will get with the help of shape. Already I have taught you. 13,000 rows are there. In fact, we have done here. Okay, 13,000 rows are there. Then what Prince will decide? Sir, we are having enough rows now. At least we are having good amount of rows, so we can divide this data into training and test. Correct or not? What does you understand from today's lecture is it is not always necessary to divide data in training and test. But sir, then when we will, how we will understand when to divide, when to not? Simple rule is there. First of all, it is not actually a rule. Common sense. If we are having very much low data, okay, only few amount of rows are there, then we cannot decide, we cannot divide into training and test data. Means we can divide, accuracy will be very much less. Why? Give as much as data in training only, na? Why to divide it into test? Correct or not? So all 100% data is in the training only. No need to divide that. So no need to do that step. Sir, what is that number then? What means what amount of rows are there? Then you will call it as big data. No one can tell you. If you are having even 100 rows na, then also you can divide in train and test. And sometimes if you are getting low accuracy, don't divide. No one can tell. Usually we should have more than 1,000 rows at least, then only it will consider as little bit good data. You can even understand. Okay, 1,000, 10,000, at least 2 lakhs. If it is more than 10,000 na, then it is good. Why? Because at 10,000 then it's good data. More amount of rows are there, divided in train and test. Okay, so we have divided into training and test. Now divide in train and test. How to divide? We already know that. And then we have applied our linear regression. Okay, sir. Linear regression we have applied. What prediction we are getting? What prediction we are getting? We are getting prediction of 225. Okay, of X test. What is actual value? It is stored in Y test. Zero value should be there, but actual value prediction value is 225. Huge error is there, sir. Huge error. Here also I can see if I am mentioning serial number as zero, some value it is written, and I don't know. We can see that for zero, serial number zero, okay, or index number zero, what is the revenue? It is zero. Okay, so predictions are going very much less. So what I'm going to do, sir, from last model, what we will do is we will copy paste the entire code, and similarly we will apply it here. Polynomial features we have imported. This is the function for implementing our polynomial regression. Okay, same, everything same is there, only x and y has changed. In the same data, downside I have written now polynomial, I can change the degrees, but when you visualize the data, you saw a very good thing here. Red spots are indicating all my actual data, and then you thought, okay sir, my data set is only not you know in any pattern. Can you see any pattern? Is it in the straight line? Is it in the curve? Can you see any pattern, anyone? No, sir. It is not even in straight line, not even in curves. So we have understood polynomial regression. But when we applied here, then we understood that with the help of that polynomial function, we cannot actually predict this. Why? Because our all the data here, actually the title is wrong. Okay. So here title should be, and this is about our big basket data. So here I will mention BB data. Okay. X axis obviously we have serial number in X. Okay, y axis we have revenue. Okay, same thing here, polynomial function has been decided, polynomial regression. This is example of linear regression, this is example of polynomial regression. What is the difference? So same line are given. Why same line is given? Because sir, my data set, my machine is confused. Why my machine is confused? Because data is not having any kind of pattern. You can see that no any fixed pattern is there right now, and that is why you can see even polynomial regression we have applied. How we understood, sir, this is polynomial? Because you saw that in this prediction we have used the polynomial function. In this prediction, simple linear regression function we have used. Okay, so two data is in front of you, linear regression, polynomial. Both data are giving me same result and inaccurate result. So why it is happening? It is not because of wrong machine learning algorithm. It is because of data set is not correct for this machine learning algorithm. Everyone understood? I've shown you one example where polynomial regression can be applied. And I'm showing you one real-time data set where polynomial regression cannot be applied. Have you understood? By practically doing it. Got it? So visualize it. So whenever you are having a data set, now you understood. Rishabh will tell me, sir, there is a common sense. Instead of doing all the linear regression, multiple linear, then polynomial, first can we draw this scatter plot? This is known as scatter plot. All these red spots are there. This is called as scatter plot. Can we draw the scatter plot? Yes. In descriptive analysis only we can draw. So there only can we decide? Yes. So when let's say Gurucharan is selected as a data analyst or machine learning engineer in any company, first task of Gurucharan will be what? He has to come to office, import all the libraries, import the data set, check how many rows and columns are there in data set, do basic descriptive analysis. What is happening? How much count is there? Mean, mode, median, everything. Okay, okay. And then draw the graph. Okay, column chart, bar chart, pie chart, and scatter chart. First of all, Gurucharan will see, sir, there is a scatter chart and I saw that there is no any pattern. 100% Gurucharan can tell, sir, don't waste time in linear regression, multiple linear regression, and polynomial regression. No, sir. Why? So no, that kind of pattern is only not there. How we will apply? And in this way, we learned polynomial regression also, and we saw that for our current data set, we cannot apply that polynomial regression. Okay, what is the proof? It is in front of you, sir. Okay, we cannot apply. So you have to write that conclusion. Okay, so this is how we decided the second algorithm also. All right. If you require this file, I will share this file also with you. You require this file? Polynomial, I will mention here polynomial regression. Okay, today is 31st of October. Polynomial regression data. Dataset is already with you. What we want is only the code. Okay, so code I'm sharing with you. Don't look at my screen, it's actually blurred because I'm downloading the data. Okay, just tell me, have you received the data? Means the code. I hope you have received the code. All right. Done. Thank you, Prince, for the confirmation. So in this way, how much we have learned, sir, in the machine learning? Just now we have stepped, and right now only regression, little bit regression we have done. Now slowly we will decide, sir, then what we have to do with the scatter plot. Okay, in the next class I will teach you next algorithm.